Hi everyone! Welcome to our learning activity videos on solutions to math packs for Senior High School General Mathematics, Quarter 1, Week 8C. And this is Part 1. Because we will have Part 2, we split the logarithmic equations and the logarithmic inequalities. For the objectives, the learner solves logarithmic equations and inequalities. But for this particular learning activity video, Part 1, we will have the learner solves logarithmic equations. Let's start. The logarithmic equation is an equation containing a variable in a logarithmic expressions, meaning those expressions that contains logarithm or log. Guidelines in solving logarithmic equations. Number 1, isolate the logarithmic term on one side of the equation. Next, write the equation in exponential form. Solve for the variable in the equation. And check to make sure you do not have extraneous solutions. For example, solve log of quantity x plus 8 to the base 5 equals 3. Solve for x. So for the solution, we copy the expression. Then, x plus 8 equals 5 cubed. The reason is equivalent exponential form. And we have x plus 8 equals 125 because 5 cubed equals 125. Then x equals 117. Subtract 8 from both sides of the logarithmic equation. Now, we have the value for x equals 117. We need to check in order to consider x equals 117 a true solution. So, we have the expression. Then, we have to substitute for x the 117. And this becomes log of 125 to the base 5 is equal to 3. So, this expression on the left-hand side is 3. And that the right-hand side is also equal to 3. So, this is a true statement. So, therefore, the solution is x equals 117. For exercise number 1, we have the direction solve for x in your answer sheet. So, we have a log of quantity 2x minus 1 to the base 3 equals 5. For the solution, we copy the original expression. Then, this is the equivalent exponential form. This is 2x minus 1 equals 3 raised to 5. So, we are now in this stage, in which case the equation is free of the logarithm or the log symbol. Then next, we have what is 243, that is equal to 3 raised to 5. The next is 2x equals 244 because we add both sides of the equation by 1 to eliminate 1 here. Then we have x equals 122. Reason is that we divide both sides of this equation by 2. And we need to check if x is equal to 122 is really a solution. So we have the original expression. Then substitute x equals 122. So we have here log of 244 minus 1 to the base 3. Is it really equal to 5? We are not yet sure. So you may write a question mark before or after the equal sign. So simplifying this is 243. So we have log or logarithm of 243 to the base 3 equals 5. And obviously, 5 equals 5. So we have hence, x equals 122 is the solution to the given logarithmic equation, log of quantity 2x minus 1 to the base 3 equals 5. For letter B, log of x squared plus x minus 1 equals 0. There is no base that is understood to be a base 10. Solution. We have here the equivalent exponential form. X squared plus x minus 1 is 10 raised to 0 or equals 1. So 10 raised to 0 equals 1. Next is we have x squared plus x minus 2 equals 0. Subtracting 1 from both sides of this equation to make right-hand side of the equation here 0. And we have this expression. Next, factoring out. So what are the factors of x squared plus x minus 2? Since this is minus 2, so possible factors of 2 or negative 2 are negative 1 and positive 2 or vice versa. But in this case, since the middle term is 1x, so it has to be that positive 2 is here and then we have minus 1. So x minus 1 times quantity x plus 2 equals 0. Solving for x, we set each of the factor x minus 1 equal to 0 or x plus 2 equals 0. Then we found out that x is equal to 1 or x is equal to negative 2. Solving for x. Checking if we have this x equals 1 is really a solution. So we have the original equation. Then we substitute x equals 1. So this is equal to log of 1 squared plus 1 minus 1 to the base 10. Is it really equal to 0? Simplifying this, we have 1 squared is 1 plus 1, that's 2 minus 1 is still 1. So we have log of 1 is equal really to 0. So 0 equals 0. So hence, x equals 1 is the solution. Next here to check if x equals negative 2 is the solution. So we have to substitute. So this becomes now log of quantity 4 minus 2 minus 1 to the base 10. Is it really equal to 0? So let's try to simplify this. That is log of 4 minus 3 is 1. So log of 1 to the base 10 equals 0. And this is a true statement. So this left-hand side is equal to 0 and equal to itself. So hence, the two solutions, negative 2 and 1, are the solution to the logarithmic equation log of quantity x squared plus x minus 1 to the base 10 equals 0. Moving on to the one-to-one property of logarithmic functions. For any logarithmic function, f of x equals log of x to the base b, if log of u to the base b equals log of v to the base b, then we can say that u equals v. So for example, we have to solve for x. Log of 2x to the base 4 equals log of 10 to the base 4. For the solution, we copy the original equation. Then, since for the base here is 4 and they have the same base on the left and the right-hand side of the equation, so we can say that 2x is equal to 10 by one-to-one property of logarithmic functions. So in this case, 2x equals 10, solving for x equals 5. Now to check, so we go back to the original expression log of 2x to the base 4 equals log of 10 to the base 4. Then substitute 5 to x, that's 2 times 5. So we have the expression log of 10 to the base 4 is equal to itself. So therefore, x equals 5 is the solution to this given equation. Let's move on to exercise number 2. Direction, solve for x and write your solution in your answer sheet. So we have log of quantity 8x minus 1 to the base 3 equals log of quantity x plus 13 to the base 3. So we copy. Then we have 8x minus 1 equals x plus 13. Why do we have to do that? We are justified by having the one-to-one property. So we end up with a linear equation from a logarithmic equation. So it's a very good transformation. If you know the rules in math, you will never get wrong. So remember the rules for logarithms. Moving on. So we have 8x minus x equals 13 plus 1. So we have to combine like terms. And we have 7x equals 14. The reason is adding like terms. Then we have to continue. 7x equals 14. Dividing both sides by 7 will give us x equals 2. Then checking if x equals 2 is really a solution, we move back to the original logarithmic equation. Substitute x equals 2. So we have the log of 16 minus 1 to the base 3. Is it equal to log of 2 plus 13 to the base 3? Simplifying, log of 15 to the base 3 is equal to itself. So hence, x equals 2 is the solution to the logarithmic equation log of quantity 8x minus 1 to the base 3 equals log of quantity x plus 13 to the base 3. Exercise number 2, letter B. We have to solve for x. In the logarithmic equation, logarithm of quantity negative 2x plus 10 to the base 5 equals logarithm of quantity 7 minus 5x to the base 5. They have the same base, so meaning by the one-to-one property, we are allowed to write negative 2x plus 10 equals 7 minus 5x. And solving for x, we have to combine like terms here. Negative 2x plus 5x equals 7 minus 10. And next is 3x equals negative 3 by adding like terms. And eventually x equals negative 1 by solving for x. Actually dividing both sides of this equation by 3. We can have that as a reason instead of solving for x. The next thing to do is to check. So check really if x equals negative 1 is a root or a solution. So plugging in the value, we have the original expression, then substitute x equals negative 1. So for x, you have it negative 1. Then you have here x, we have negative 1. Because we have to simplify, negative 2 times negative 1, we have positive 2 plus 10. So we have log of 12 to the base 5. Is it equal to the expression here, log of 7? Negative 5 times negative 1 is positive 5. So 7 plus 5 is 12. So we have log of 12 to the base 5 is equal to itself. Hence, x equals negative 1 is the solution to the logarithmic equation log of quantity negative 2x plus 10 to the base 5 equals log of quantity 7 minus 5x to the base 5. Laws of logarithm. We have 3 laws here, the product law, the quotient, and the power law. Let me read. Let b be any positive real number not equal to 1. And n be any real number. For any positive real numbers, u and v, the following properties are true. We have here product law equals log of quantity u times v to the base b equals log of u to the base b plus log of v to the base b. That's the product law. Quotient law, we have log of quantity u divided by v to the base b is equal to log of u to the base b minus log of v to the base b. That is the quotient law. Then we have the power law. Log of u raised to n to the base b is actually equal to n times log of u to the base b. Now let's apply these rules to some examples. Example 3. We have solved for x for log of x to the base 2 plus log of quantity x minus 6 to the base 2 equals 4. So we copy the original equation. Then, since this is plus, so we can multiply x times quantity x minus 6. So we have here the log. Then this expression I mentioned earlier to the base 2 equals 4. Applying the product law. Then we have x times quantity x minus 6 equals 2 raised to 4. This is the equivalent exponential equation of the given logarithmic equation. Then we have to distribute x times x here, x squared, x times negative 6 is negative 6x, and equals to 2 raised to 4 is 16. And of course, we have to make the right-hand side 0, so we subtract 16 from both sides of the equation to make this here 0. So we have x squared minus 6x minus 16 equals 0. Then we factor this out as the factors are x minus 8 and x plus 2. Equate that to 0, and then solving for x, we have to equate x minus 8 equals 0, and another one is x plus 2 equals 0. And we have the values of x equals 8, and the other one is x equals negative 2. We have the note here. If we check, if x is negative 2, then log of negative 2 to the base 2 is undefined. We cannot have that. Plus log of negative 8. Why negative 8 here? We have because negative 2 minus 6 is negative 8 to the base 2. Is it equal to 4? This expression does not exist because it has to be that these numbers here are non-negative, are always positive. Thus, x equals negative 2 is not the solution to the equation. It appears to be the solution, but it is what we call an extraneous solution. The only solution of the above equation is x equals 8. Now let's try to do some mental math. We apply x equals 8, substitute it here to the original one. So if log of 8 to the base 2, that is 3. So pending 3 plus 8 minus 6 is 2. So what is log of 2 to the base 2? It's 1. So we have earlier a 3 plus 1 is 4. So that's how to check it mentally. Now we move on to exercise number 3. We have directions, solve for x, and write your solution in your answer sheet. Now for letter A, we have the expression log of quantity x plus 4 to the base 3 plus log of quantity x minus 4 to the base 3 equals 2. For the solution, just copy here, and then we apply the product law. Because there is a plus sign here, the whole logarithmic expression here, then another logarithmic expression, and they have the same base 3. If it's like that, then we can apply the product law. We can put them under one logarithm of quantity x plus 4 and then multiply it to x minus 4 to the base 3. Then we copy equals 2. Then we transform to its exponential equation. So we have equivalent exponential form. This expression equals 3 the base squared, the logarithm 2. And we have x squared minus 16 equals 9. Simplifying further, we have x squared minus 25 equals 0. Why do we have 25? We have subtracting 9 from both sides here to make it 0. And then we know that this is a difference of two perfect squares. So factors are x plus 5 and x minus 5. Equate that to 0. Then that's by factoring. Then set this factor x plus 5 equals 0 and x minus 5 equals 0. And x equals negative 5 or x equals 5. Solving for x. Let's do the checking. If x is negative 5, we have log of quantity x plus 4. So we substitute negative 5 here. So negative 5 plus 4, that's negative 1. So log of negative 1 to the base 3. Then negative 5, so that becomes negative 9. So log of negative 9 to the base 3, is it equal to 2? Now this does not exist. If you try to recall quarter 1, week 8A of your learning activity sheet, reminder number 2 says in the logarithmic form, log of x to the base b, x cannot be negative. So remember that. Hence, x equals negative 5 is an extraneous root to the logarithmic equation. Moving on to check if x equals 5 is a true solution. So we have 5 plus 4, that makes it 9. So we have log of 9 to the base 3. That we have 5 minus 4 here. So that is log of 1 to the base 3. Is it really equal to 2? Let's see. What's the logarithm? Meaning, what are we going to raise to 3 to make it 9? So 3 squared is 9, or x here is 2. So we have the answer is 2. And here, what are we going to raise to the base 3 to make it 1? That is 3 raised to 0 equals 1. So 2 plus 0 is really equal to 2, or 2 equals itself. So then, hence, x equals 5 is the solution to the logarithmic equation given. For letter B, we have log of quantity x plus 5 to the base 2 minus log of quantity x minus 2 to the base 2 equals 3. Solution. So we have applying the quotient law. We put them under one logarithm. Let me read. Log of quantity x plus 5 all over x minus 2 to the base 2 equals 3. Then we have x plus 5 all over x minus 2 equals the base 2 and the logarithm 3 by equivalent exponential equation. And we have here simplifying 2 cubed equals 8. And moving on further, we have here x plus 5 equals 8 times quantity x minus 2. That is multiplying both sides by quantity x minus 2. And distributing 8. And we have here combining like terms. So we have 5 plus 16 equals 8x minus x. We have 7x. Here, 8x minus x is 7x. Is equal to 5 plus 16, which is 21. Adding like terms. And finally, dividing both sides by 7 will give us x equals 3. To check whether x equals 3 is a solution, we have to replace here 3. So log of 3 plus 5, that's 8 to the base 2. Then minus log of 3 minus 2, that's 1 to the base 2. Is it really equal to 3? So here we know that the exponent that we're going to raise to 2 to make it 8 is 3. So log of 8 to the base 2 is 3. Minus log of 1 to the base 2 is always 0. So 3 minus 0 equals 3. So 3 equals itself. Hence, x equals 3 is the solution to the given logarithmic equation. For our enrichment activity, directions, letter A, solve the following logarithmic equations. Write your solutions in your answer sheet. For number 1, we have log of quantity 7 minus 2x to the base 3 equals 2. Solution. We have here 7 minus 2x equals 3 squared. Equivalent exponential equation. Then 7 minus 2x equals 9. Well, because 3 squared equals 9. And 7 minus 9 equals 2x. Combining like terms. Then we have 2x equals negative 2. Adding like terms, and eventually x equals negative 1. Dividing both sides of the equation by 2 to get the value for x. So let's check x equals -1 to the original expression. So this is -1 here. That becomes 7 plus 2. So that becomes log of 9 to the base 3. Is it really equal to 2? Yes, it is. So 2 is equal to 2. Hence, x equals -1 is the solution to this given equation. For number 2, we have 2 times the logarithm of quantity x minus 2 to the base 10 equals 4. For the solution, rewriting this given, we apply the power rule or the power law. So instead of having 2 here, we can move it to the exponent of quantity x minus 2. Let me read. Log of quantity x minus 2 squared to the base 10 equals 4. Moving on. So we can have x minus 2 quantity squared equals 10 raised to 4. That is equivalent exponential equation. Expanding this term, we have x squared minus 4x plus 4, and that is equal to 10,000. And simplifying further by combining like terms or subtracting 10,000 from this side, we have x squared minus 4x minus 9,996 equals 0. And we have to factor this out. Factoring is the best method. So we have the factors x plus 98 and another one is x minus 102 equated to 0. Moving on, we have setting each factor equal to 0 and solving for x. We found out that x is equal to -98 and another one is x equals 102. Checking for x equals -98. So we have to substitute it here. This will become -100. But take note, -100, you square it, it will become positive. And this is log of 10,000 to the base 10 is 4. And it's really true. So therefore, 4 equals 4. Next, checking if x equals 102 is still a solution. So the original logarithmic equation, substituting 102 minus 2 here, that becomes 100 times 2. So evaluating this part, we have, this is log of 100 to the base 10 is 2. Times it by 2, it's 4. 4 equals itself. Hence, the two values for x are -98 and 102 are the true solution to the logarithmic equation given. Next, number 3, we have log of x to the base 10 equals log of quantity x minus 2 squared to the base 10. Solving for x, we have, okay, copy the given. Then we have it here. We have a minus sign, making the right-hand side 0. So isolating the log term on one side of the equation. Now, since we have the minus, you can put them under one log, and this is equal to x divided by this expression quantity x minus 2 squared to the base 10, and that is equal to 0. So applying the quotient law. Moving on, we have to apply the equivalent exponential form. This becomes x over quantity x minus 2 squared, and that is equal to 10 raised to 0. Next, we have it here, and we isolate this x, multiplying both sides of this equation by this quantity or this expression quantity x minus 2 squared to make it a linear equation. Then, let's try to swap. So expanding this, we have x squared minus 4x plus 4 equals x, the reflexive property. Then, we have to move x to the other side. That becomes x squared minus 5x plus 4 equals 0, leaving the right-hand side 0. And after that, we set each factor equal to 0. But what are the factors here? We have quantity x minus 1 and x minus 4. Solving for the factors or the values of x that will make this factor 0, so we have x equals 1 or x equals 4. Now let's check if x equals 1 is the solution. Okay, so log of 1 to the base 10, we have it here. Is it equal to log of 1 minus 2? This becomes negative 1, but we have the square, so it becomes positive. So obviously, log of 1 to the base 10 is equal to itself. Or if you press the calculator, log of 1, it's 0 and equals itself. For another value, x equals 4, we have to substitute here. Log of 4 to the base 10, is it equal to log of quantity 4 minus 2? This is 2 squared, that's log of 4, so that's equal to itself. Okay, so hence the two solutions x equals 1 and 4 are the solutions to the given logarithmic equation. For number 4, we have log of x to the base 2 plus log of quantity x plus 1 to the base 2 equals 1. Solve for x. We have here the given, and then what do? Well, we apply the product law because of the plus sign here, and they have the same base, so we have to move or to put them under one base. So log of x times quantity x plus 1 to the base 2. Copy the equal to 1. Then we have to transform to its equivalent exponential equation. So x times quantity x plus 1 equals 2 raised to 1, or simply 2. Then we have to make this side 0 by applying distributive property and the addition property of equality. Let's do that. X times x squared. X times positive 1 is plus x. Then we have to add negative 2 both sides, that is addition property of equality. So this becomes 0 and this becomes negative 2 here. So that justifies it. Then we have to factor out this expression. The factors are x minus 1 and x plus 2 equated to 0. So then set each factor equal to 0 and solve for x. So we found out x equals 1 and x equals negative 2. So either of this, either x equals 1 or x equals negative 2 is the solution to the given logarithmic equation. Let's proceed further for the checking. If x is equal to negative 2, we have here log of negative 2 to the base 2, it's negative. Then log of negative 2 plus 1, that's negative 1 to the base 2. Well, these expressions do not exist. So hence, x equals negative 2 is not a solution, or we can say is an extraneous solution. Let's move to the other value of x equals 1. So substitute log of 1 to the base 2 plus log of 1 plus 1, it's 2 to the base 2. Is it really equal to 1? The whole thing here is 0, and this one is 1. So that is equal to 1. So 1 is equal to itself. Hence, the only solution for this logarithmic equation is x equals 1. For number 5, we have log of quantity x plus 1 to the base 2 minus log of quantity x minus 1 to the base 2, we have equals 3. Copy, and then we have the solution applying the quotient law because they have the same base. Log of x plus 1 over x minus 1 to the base 2 equals 3. Then showing the exponential form, and of course 2 cubed is 8. So we have here this one, and multiplying both sides by x minus 1, we have the linear equation from a rational equation. So x plus 1 equals 8x minus 8. Applying distributive property here. And then we have combining like terms. We have here 7x equals 9. Adding like terms. Then finally x equals 9 over 7 or 9/7. Dividing both sides of the equation by 7. To check whether this is really the solution, that we have log of the original expression, we substitute x 9 over 7 plus 1 here, minus the log of 9 over 7 minus 1 to the base 2. Is it really equal to 3? Now let's have this one. This is a simplified one. 16 over 7 here and 2 over 7. So we have to put them under 1 log 16 over 7 all over 2 over 7. This one cancels out the 7. And by the quotient rule. So we can do that. Since we have it there, that becomes 16 divided by 2 earlier. So we have 8 to the base 2. That's 3. This is 3 and equals 3. So 3 equals itself. So hence, we have proven that x equals 9 over 7 is the solution to the given logarithmic equation. So for the last one, we have letter B for the enrichment activity. This is a bit higher level order thinking skills proving, but there's a trick that I'm gonna teach you so that you will be able to prove that this is true. Prove that logarithm of a squared over bc plus log of b squared over a times c plus log of c squared over a times b equals 0. You will notice that if a is in the numerator, the b and the c is below. If b is in the numerator, there's no denominator b here. And if c is in the denominator, as long as it is squared, there is no c down below. Now, what can we apply here? Because it involves plus. And one thing more, they don't have, the base is not seen here. So that means that the base is understood to be 10. So we can apply the product law. So for the proof, we just copy the original expression. Then, since they have the same base, 10, we can put them under one logarithm. So we can multiply a squared over bc times b squared over ac times c squared over ac, then equate it to 0. Applying the product law. Then we have to multiply all the numerators, the log of a squared b squared times c squared, all over, we have to multiply also the denominator. And in this case, we found a squared, we also have b squared, we have also c squared. So meaning the numerator and denominator are the same. So that means equals 1. So log of 1 to the base 10 is equal to 0. And we have, that is the multiplication fact in here. And next is hence the expression is true. Okay, so we have proven. So we're done. Thank you for listening. And this is Teacher Marichu. Say always stay happy, healthy, and safe. And don't forget to like, share, and subscribe to this channel so you will be updated with the latest video on learning activity and mathematics that I'm going to upload. Thank you and God bless us.